I'm Anil Kumar. Welcome to my series on calculus. We have picked a few questions for exam review, and I hope they will help you prepare for your own test. This question is based on communication and application. The question is, consider a function f, the line L1 with equation y equals to 3x plus 1 is tangent to the graph of f when x equals to 2. Based on this, we have four questions. Write the value of f prime 2, find f of 2, c. Let g of x equals to f of x squared plus 1 and p be a point on the graph of g where x equals to 1. Show that the graph of g has a gradient of 6 at p. And d is, let L2 be tangent to the graph of g at p. L1 and L2 intersect at the point Q. Determine the y coordinate of Q. You can always pause the video and answer the question. Here is my solution. So let's try to understand the situation. The question is, consider a function f, the line L1, where the equation y equals to 3x plus 1 is tangent to the graph of function f. So we really don't know what is the graph of the function x, but we know that at a particular point, we have a tangent line, and the slope of this tangent line should be 3, correct? So if I draw a line here, so consider a function f. So let us say the function here is f. The line L1, this is the line L1 which we're talking about, with equation 3x plus 1. So if the equation is 3x plus 1, the slope is 3, right? So this is the line 3x plus 1 is tangent to the graph of f at x equals to 2. So at this particular point, we have the value of x equals to 2, right? So as far as function is concerned, the gradient of this gives you the gradient at this particular point. So basically, f dash of 2 should be equal to the slope of the line, which is 3. Is that clear? Since the line is tangent. Perfect. So that is the logic with which we'll go and answer part A. So part A is write the value of f prime 2. So we just figured out. So it is equal to slope of the line, tangent, right? L1, correct? And therefore, we can write this as the answer, which is f prime 2 is basically equal to 3. Is that clear to you, right? So that becomes the answer for this particular question. Now the question is to find the value f of 2. Now the value will be, because the point is also on the line, so we can say f of 2 is basically equal to, substitute 2 here, so we get 3 times 2 plus 1, which is 6 plus 1, that is 7. So that is the value at 2. Part C is, let g of x equals to f of x squared plus 1 and P be a point on the graph of G where x equals to 1. Show that the graph of G has a gradient of 6 at P. So let's take it on the fresh page. So let's do part C now on a fresh page. So, well, now here we are working on this particular part. So basically, let this be the function and P be a point on the graph of G where x equals to 1. Show that the graph of G has a gradient of 6 at P. So we have to find G prime, right? So we have to prime G prime is 6 at P and P value x is 1. So that should be equal to 6. This is what we need to show, correct? So that is basically the function. Now to do this, what we can do is we have the function itself. So what is G prime x equals to? Now that is a function. So function gradient, right, times the gradient of inside function, right, times d dx of x squared plus 1. So that could be written as f prime x squared plus 1 times derivative of this is 2x. Correct. Now, since we want this to be at 1, so g prime at 1 will be equal to, let's substitute 1 here. So f prime at 1 plus 1 times 2, which is 2 times 1. So we are looking for f prime at 2 times 2, right? So what is f prime at 2? It is given to us as f prime of 2 we just calculated, which is the gradient, right? So we just calculated this, that f prime at 2 is 3. So we're going to substitute this value 3 here and then calculate our answer. So f prime of 2 is 3. So we have 3 here times 2, and that gives us the answer as 6. And that is what we wanted to show, right? So we have shown that the gradient at P is indeed 6. Clear? The last part here is, let L2 be the tangent to the graph of G at P. L1 and L2 intersect at point Q. Determine the y coordinate of Q. So let's do it on a fresh page. We need to find the y coordinate of Q. A similar situation. Now, we really have little space here. So what I will do is I'll push the page up so that we can make some room to solve the problem, right? So that is the question for us. So we need to find the equation of line L2 basically, right? L2. Now to find the equation of line at L2, we need two things. First is the slope, and second, we need to have a point, right? So it says that let L2 be tangent to the graph G at P. So it is tangent at P, and we know what point P is. We just calculated P, right? So we know what point P is, and at P, we need to find the value of this particular function, right? Now, in this particular case, we can write down that and the gradient is also known to us. We found that the gradient at P is 6. Two things, right? So let's write down what is given to us. So for this equation, we know G dash at x equals to 1 is indeed equals to 6, and point P is 1, 7. So that's the point given to us. So from here, we can find the equation of line L2, which is, we can write this as y minus y1 equals to m times x minus x1. So we get y minus y1 is 7 equals to slope is 6, x minus 1. So we have y minus 7 equals to 6x minus 6, or y equals to 6x minus 6 plus 7, which can be written as y equals to 6x plus 1, correct? So that is the equation of the line. Now, let L2 be tangent to this graph. So we have used all this information because L2 is tangent to this graph at P. L1 and L2 intersect at Q. Determine the y coordinate. So we need to find the intersection of L1 and L2. So the equation of L1 was given to us, which is 3x plus 1, right? So this is the equation of L1. So let L1 be 3x plus 1. Now we have already found that L2 is y equals to 6x plus 1, correct? So this is L1 as y equals to 3x plus 1, right? So we got these two equations, and we're looking for their point of intersection. So, so basically you can equate them, but you know the y-intercept seems to be the point of intersection. So point of intersection. So we could do 3x plus 1 as equal to 6x plus 1. So that is, we have 3x equals to 6x, and that is possible only when x is 0, right? So that is when x is equal to 0. So when x is 0, we need to find the y coordinate, which is the y-intercept, which we could see as 1 as common, right? So we could write this as y equals to, substituting x equals to 0 in any one of those equations, we get y value of 1. Correct? So we know the point of intersection is basically 0, 1. So we say y equals to 1 is our answer. Correct? So that is how we have to give this information. Well, in the question, we were supposed to give also the point P as given to us as 1, 7. Okay. So that was the point P given to us, and we used the value 7 in our calculation. Correct? So that is how we are going to answer this particular question. So with that, we have the solution to our question, which is based on uh, tangents and the intersection of tangents. Perfect. I hope you find it interesting and useful. Thanks for your time and all the best.